So this is future Raphael, I guess, talking. I really wanted to make one video introducing the CNC, the rotary CNC plasma cutter, and instead it's going to be two videos. You know, enjoy me showing you the rotary CNC plasma cutter cutting round tube. It's a 27 millimeter, 3 millimeter thick tube, and it's just a demo cut. And yeah, you're going to see that in the next one. You're going to see me take a step at the HSS. I'm going to split it up because right now my primary focus is I'm building my own house. So all my effort goes into this, and the rotary CNC plasma cutter takes the back seat. It's only here for, well, the farm business. So I'll have a few gates and some panels that I need to build with it in the close future. But that's about it. Anyway, so without further ado, enjoy the machine working. What you just witnessed is literally the second cut ever with my rotary CNC plasma cutter. It's a home built version where I fixed an issue that I previously had, because SimCNC, the software I use for running the controller, it does not support inverse kinematics, which I believe is G93, and because of that I have to do S-curve profiling and ADLS for speed dampening and all these good things in software myself, right? And it is, as it turns out, to basically simulate the correct G93 behavior. It's very complex. So it took me a while to, you know, just twiddle around with the software. Let's take a look at some of these cuts here. When you take a look at the video, I think you will see that it was moving a little bit aggressive. It did cut through, but I think if it was cutting just a little bit slower, the cuts might have been better. What I had in my computer, a hexagon of round stuff. Okay. Pretty darn close to the model, I'd say. Okay, so this is my hexagon. It's a little bit tricky to prop it up. And then I also had like fish mouths like this, which sit on here to, oh, see, I should have modeled this differently, to basically act as legs. So I think I'll have to next time I will show the 3D model for this. What I guess what I have to account for is always the inside wall here is where this sits on, and I use the outside wall. So I modeled this wrong in Fusion 360. Anyway, so you have 3 legs. They're supposed to sit here, here, and here. Now let's be very critical and let's take a look, right? First thing you see, I started in the actual piece here. My starting cut should have been on the left of this. So this is something I'll have to fix in my software. But the rest of it, I'm actually surprised how this came out. You can see that I cannot tilt my plasma cutter, and I can also not roll it, which means I basically always get the cut from the top. So this was, I believe, the start, and then as it rotates, you have always a 90 degree, right? Which leads to this weird taper look like, because this is a 90 and this is a 90 and here's a 90. So you basically have that, you know, path that walks around. So obviously to get a really good fit, I have to do a little bit of grinding. So, but hey, this is pretty cool. Let me do that little bit of grinding here. And then we're going to fit this together again. And I have something I have to fix in my software. But before we do that, let's take a quick look at the software I wrote, so that you have some understanding of, you know, the flow that I'm aiming for here, because this needs to be convenient, and I think I'm pretty close to a convenient solution. Also, look at these. They are all standing exactly how they were supposed to, which is pretty crazy. Again, right, this thing here, modeling mistake on my side, but that's pretty nice actually. All right, so this is where you see the actual design in Fusion 360. You can see you have your your hexagon here, and then you have your 3 tubes, right? Fairly straightforward. And here you can also see my modeling mistake, because obviously this here is the outside corner, but the inside, the wall thickness here at the top, would need to be a lot thinner to actually sit like this. And if I could angle my torch, I could cut like that. But I only have an XYZA plasma cutter in this case. I can't roll or pitch my plasma torch, which is why this angle here, I actually can't do this. This needs an offset. Anyways, so I designed this, right? And then I go into my own software. I put into my own software. There we go. And then you load it in here. In this case, it's this file. Takes a second, and now you can see the same design as I had in Fusion 360, right? It automatically detects on the top right that this is a round profile, and then I can select which components I want to cut, right? It automatically positions them on your stock. So let's just say I want to cut all, right? You can see here at the bottom I have all the different components. If I go over it, it highlights me so I know what I'm actually looking at. I have a small simulation in here, which also highlights the cut paths. You can see this at the right, the yellow lines. There you go, exactly. So you see how the machine would cut this. Obviously, it's just for visualization. The paths that actually generated are smooth. Right, and then I can also go in here and say, you know what, I want 3 of these, for example, or, you know, I only have like a 20 centimeter stock, and then it automatically subdivides this into however many stocks it has. So it's a fairly interesting piece of software. You can see my yellow boxes here. It just highlights how to segment these things, and it optimizes literally for least amount of scrap. And it also does heat distribution to make sure that I don't warp my steel too much when I cut it. All the good stuff basically is in here. And then let me actually make this longer again, it's easier. I generate G-code, right? I get my G-code out of here. I'm not going to export this right now. And then I can go into SimCNC, which is the software I use for cutting. And then I open this in SimCNC. Exactly, download. Yeah, it's fine, you can access the downloads later. Well, eventually, I guess my Mac will allow me to click Mac. Allow. Seriously, software, it's 2026, and software, computers got so much faster. And everything still hangs everywhere, even on my local system. Like, come on, people. Apple, if you see this, you have to do better. This sucks. All right, when you finally are allowed to open it, you can see it here. And then you see the G-code this generated. Right, and then you can also see the preview of how this looks like. Now, do mind that this is a pipe I'm cutting, right? So there's no movement on the Y or Z axis. So this is why pretty much all the movement you have here is on X and A, right? And sure. And then in my planning mode, I can actually see this executing, and you can see how the machine here moves and cuts, right? So all of this is good. It's basically the same thing you saw here. This works fairly well. I mean, getting SimCNC to work honestly was quite simple. The biggest issue that I have and still have with SimCNC is the fact that SimCNC does not support inverse kinematics, like I mentioned. So my software is so complicated because I have to resolve the inverse kinematics and then just feed a lot of point movements to SimCNC for it to actually execute, right? And that's, honestly, it sucks. But it's on their backlog somewhere, right? Now, let's take a quick look here at the machine. I already posted a bunch of videos for it, right? But still, you can see the front here, right? The rotary chuck. This is something Tamar has a very similar design on YouTube. And I literally looked at it and I thought, this is great, I can copy it. So I copied it, works very well. You can see right now I don't have my tensioning belts on here because the ones I bought, they were too short. So you see this here. I think I mentioned this in one of my videos. This is actually a Z-axis that I bought from Calf Cut CNC. Never going to go to buy from them again because honestly, I should have just bought the Z-axis probably from Fast Cut CNC. They have a much nicer Z-axis. Anyways, the shed here, the sled where it runs on, you can see this is Fast Cut. Shout out to my Fast Cut folks. The integration worked great. I don't know how many people buy CNC hardware from Fast Cut. Maybe you should consider it. The only issue that I have with this thing here, I don't know why the ohmic clip actually doesn't work. So usually on the other machine, when I touch the workpiece with the ohmic clip, it registers. And for whatever reason, it doesn't work on my system. So the pinout is per what they said. I guess I'll have to hit them up and ask them to help me debug this eventually. Anyways, so you see the sled here, right? Two sensors, left, right, and then you have the stop box here, symmetric on each side. That works nicely. And I only have to run this every once in a while to get the motor here centered again. You can see self-tensioning mechanism, modulus 1.5 rack and pinion, the same as I have here. I have intermediate supports that can move with the cartridge, and they're only here to make sure that the stock doesn't sag, right? K72-100 chuck. Because I have direct workpiece grounding all of the chuck itself and also the front. You can see it here, this here. That's FR4 PCB material, and I physically insulated this. So the only way this piece can ground itself is through my home built rotary ground here at the back and the ground system here in the front, right? The front system is spring mounted, the back system is spring mounted, and then this entire system can just move forward and backwards. These here are Technic servos. If you don't know, if you move a lot of mass and I want to literally cut 6x6 HSS with this machine, then you do need servos, you just need the power. Stepper motors don't work too well. And then you have the control box there, and obviously my control station, which I can rotate a bit. Not a whole 360 degrees because of the cables floating around, but much better. second attempt here after a little bit of grinding. Look how nicely that fits. Wow, that is crazy. That's really nice. It's literally just the pitch and rolling of the torch that I'm missing here to get really nice results, you know. I'll arrange this and weld it up, and then we're going to switch to some rectangular tube and see how that cuts.